Alright, boys and girls, we are doing a great job understanding shapes and their different attributes. In today's lesson, we will learn how to divide and talk about shapes when split into equal parts. Our objective, students, is that students will be able to interpret equal shares in composite shapes as halves, thirds, and fourths. Let's do a quick review on our last lesson. In our last lesson, we talked about tangram puzzles. A tangram puzzle is made out of many different geometric shapes that create one large shape. In our case, a square. When we combine shapes to create a new one, we are actually creating a composite shape. I hope you had fun constructing many different shapes. Now let's take a closer look at some of these composite shapes. Let's begin with the triangle. Notice this triangle on top? Let's say we split it in half down the middle. We see that we actually have two smaller triangles that are of equal size. We can say that this triangle is then composed of two equal parts or two equal shares or two equal halves. We can actually write this as a fraction known as 1/2 or 1 over 2. Fractions represent a part of a whole. In this case, the 1 represents one of the parts of the triangle that is known, and the 2 represents the total number of parts that make up the whole. The top number of a fraction is always known as the numerator, and the bottom number is known as the denominator. Think of fractions as representing parts of a whole. We can also split other shapes in half. We can split a square. We can divide a square into two rectangles, down the middle, or even across. If we actually were to split the square diagonally on either end, we would actually have two equal triangles as well. A parallelogram can also be divided into two halves, or in this case, two triangles. Also, can we create halves by combining any shape? Let's take a look. We have this triangle and we have this rhombus or parallelogram. Do they look like they create two halves? No, we know they don't create two halves because these shapes are not equal. Fractions need to consist of equal parts. Let's take a look at the hexagon. If we divide it in half across, we're actually creating two smaller polygons that are of equal shape, and we see that we have two trapezoids. Again, one trapezoid would represent 1/2. This hexagon can also be split down the middle, going vertically, just like we have seen with the square. See, so it can be divided vertically or horizontally. Either way, it still represents two halves. We also have a trapezoid. When we look at this trapezoid, we can actually fit three triangles, equal triangles, into the trapezoid. It's divided into three equal parts, or three equal shares. It's known as thirds. One triangle would represent 1/3. The fraction is written as 1/3, with the 1 representing one of the parts and the 3 representing the total number of equal parts. In this case, triangles that are used to create the whole. And the whole represents the trapezoid. We can also split other shapes into thirds. We can take, for example, a hexagon, and it can be partitioned or split into three rhombi. Finally, let's take a look at the square. We can divide the square into two equal halves, as we've discussed earlier, but we can also divide it into 4 equal parts, in this case 4 squares. and this is known as fourths. And when we're just talking about one of the squares, or yes, just one of the squares, we can write this as 1/4, with 1 representing one of the squares or one of the parts, or one of the equal shares, and the 4 representing the total number of equal parts that create the square or the whole. Today, you will be working on dividing polygons on your own and labeling them as halves, thirds, and fourths.